In the realm of science, enormous privileged insights into the topic of existence ahead of time have had a huge impact. These intertwined conversations have piqued the interest of scholars and thinkers for a very long time. This Goliath request tests more than just our methods, it could disentangle the universe. It challenges the very limits of human knowledge. Standing on the brink of discovery, we examine the gigantic shadows of the past and consider what existed before our universe was imagined. The Big Bang, which marked the beginning of history, the universe, and everything we are, raises a crucial question: what came before it? Regardless, we must acknowledge that there was a moment, perhaps just before the explosion, a state of calm before the chaos. But was there truly nothingness? Or was there something even more profound, perhaps even traumatic, that existed long before time? As we delve into this scientific inquiry, we embark on a journey beyond the known universe, into ideas that challenge the very foundation of our understanding. Physicist Brian Cox, well known for his dedication to exploring the universe's mysteries, suggests that something shocking may have preceded the Big Bang. He urges us to reconsider how we perceive reality and existence itself. In this evaluation, we will break down the science, the speculative theories, and the astonishing secrets that could explain what came before. Before we begin, we must explore concepts like God's improvement, quantum mechanics, dark energy, and multiverse. The revelations we uncover may overwhelm us, but they could also provide new perspectives on our place in the universe. We are about to plunge deep into a realm where science and imagination collide, a place where the unknown continues to cast its shadow, leaving scientists both intrigued and, at times, frustrated. So, what was present before the Big Bang? And why do these theories challenge everything we thought we knew? Scientists describe the Big Bang as an event during which the universe became extremely hot and dense, expanding rapidly to give rise to all matter and energy. But when we look at the cosmos, we find no clear boundaries. We observe galaxies moving outward, originating from a single point. Why did this happen? Was there a time before this expansion began? According to the theory of cosmic inflation, the universe existed before the Big Bang in a cold, empty state, much like an enormous vacuum. However, this vacuum wasn't truly empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that its cause remains one of the great mysteries of cosmology. It is believed that inflation caused the universe to expand at extraordinary speeds until the expansion slowed, and the energy transformed into matter, forces, and everything we now associate with the Big Bang. But what was the nature of this energy? Where did it come from? Why did it stop? Scientists theorize that this eternal expansion resulted in different patches of the universe, each experiencing its own Big Bang. Imagine an ever-expanding material forming tiny air bubbles. Each bubble represents a universe, including our own. This concept, known as the inflationary model of the multiverse, suggests that an infinite number of Big Bangs may have occurred, leading to countless universes. This incredible idea challenges our understanding of reality, raising the question: what else might exist beyond our observable universe? The notion of nothingness before the Big Bang is purely theoretical. Even if we remove all energy, particles, and radiation from the universe, it would not be truly empty. The universe remains filled with dark matter, dark energy, quantum fields, and fundamental forces that create an intricate cosmic framework. Even in the absence of these forces, the universe would still generate new forms of energy. This realization baffles scientists, as it implies that true emptiness may be impossible. Space itself has properties, rules, and constants that prevent it from being completely void. Imagine constructing a region devoid of particles, radiation, and energy, yet quantum fields and large-scale constants would still remain. This suggests that even nothingness has properties. For example, the theory of zero-point energy describes the lowest possible energy state of quantum fields, in which virtual particles appear and disappear, creating a constant state of fluctuation. This challenges our very definition of a true void and indicates that, yes, even before the Big Bang, something existed. Scientists continue to explore this concept, as it may be one of the most astonishing ideas in modern cosmology. If inflation could create our universe, it's possible that it continues to generate new universes endlessly. Brian Cox describes an unimaginably vast multiverse, in which new universes are constantly born. Each Big Bang could be seen as a spark igniting a new universe, while inflation continues in different regions, creating an infinite cosmic network. This concept suggests a fractal-like reality, where each universe may give rise to its own Big Bang. Each universe exists independently, unaffected by others due to the rapid expansion of space. For researchers, this hypothesis is both exhilarating and unsettling, as it implies an endless multiverse with no clear beginning or end. Now, imagine our universe as just one tiny part of an infinite cosmic blueprint, always evolving, always creating new universes. What if that is the true nature of reality? What if there is no before or after, only a timeless cycle of universes shaping existence itself? We must reconsider our understanding of nothingness. The theory of quantum fields suggests that space is not merely an empty void but rather a complex, interconnected network of energy fields that permeate everything. If this is true, then the nature of reality is far more intricate than we ever imagined. If our universe is just one among countless others, it raises even deeper questions. Are the laws of physics the same in every universe? Do other universes contain different forms of matter, energy, or even dimensions beyond our comprehension? Some theories suggest that physical constants, such as the strength of gravity, the speed of light, and the properties of fundamental particles, could vary between universes, leading to wildly different realities. One of the most fascinating ideas emerging from this discussion is the concept of an eternal, self-replicating cosmos. If the inflationary model is correct, then the process of universe formation never truly stops. Instead, quantum fluctuations cause inflation to continue in certain regions, perpetually generating new universes. This would mean that there was no absolute beginning, just an ongoing process of cosmic creation, stretching infinitely into the past and future. But if time itself began with the Big Bang, how can we speak of anything before it? Some physicists argue that time, as we perceive it, is merely a feature of our universe. In other words, time may be an emergent property rather than a fundamental one. Before the Big Bang, there may have been a timeless realm, an existence where cause and effect, as we know them, did not apply. Theoretical physicist Roger Penrose has proposed an idea called conformal cyclic cosmology, CCC, which suggests that our universe is just one in a series of repeating cycles. According to this theory, each universe ends in a vast expansion, where all matter and black holes eventually evaporate, leaving behind an empty space filled only with energy. This empty universe, through a strange mathematical transformation, could become the seed for a new Big Bang. If true, this would mean our universe is not the first, and it will not be the last. Other models propose that the Big Bang was not the absolute beginning but rather a transition from a previous state of existence. Some physicists theorize that our universe may have emerged from the collapse of a previous one, suggesting a cyclical nature to reality. This idea is supported by certain interpretations of quantum mechanics and string theory, which hint at a pre-existing structure that gave rise to the Big Bang. One particularly intriguing idea comes from the concept of the ekpyrotic universe, which suggests that our universe was born from the collision of two higher-dimensional spaces, or brands. In this scenario, our three-dimensional universe exists as part of a much larger, multidimensional reality, and Big Bang-like events occur whenever these higher-dimensional structures interact. If this is the case, then our universe is part of a far greater cosmic framework, one in which entire realities are created and destroyed as part of an eternal dance of dimensions. This perspective challenges the idea of a singular beginning and suggests that existence itself is infinite, constantly shifting and reshaping in ways we are only beginning to understand. These theories push the boundaries of human knowledge, forcing us to confront the ultimate question: what is the true nature of reality? Is the universe a grand, unfolding story with a definitive start and end? Or is it an endless, self-sustaining system, beyond the limits of our perception? As we continue to explore these mysteries, we may one day discover answers that redefine our understanding of existence. Until then, we stand at the edge of the unknown, gazing into the depths of time, space, and possibility, wondering what lies beyond the horizon of our cosmic origins. The universe interacts to create everything. These fields are comparable to intangible seas, with particles acting as disturbances or waves. Even when fields are at their lowest known energy level, the vacuum state, they are still active. Particles can appear and evaporate quickly in these fields, gaining energy before giving it back. This quality results in virtual particles that exist briefly, then vanish, leaving only a faint memory of their presence. The challenges of virtual particles and the viability of an actual void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you really have nothing? According to quantum field theory, you wouldn't. Fields would remain even in a vacuum, dynamically fluctuating with occasional lapses. This ongoing particle activity suggests that the universe doesn't conform to our traditional concept of emptiness. Forces and fields endure, injecting energy into the universe even when it appears to be void. This understanding raises a fascinating question. If fields create particles, and matter arises from particles, could the universe have emerged from this nothingness filled with quantum fields? Dark energy and the universe's expansion. A strange force, known as dark energy, currently drives the universe's accelerated expansion. But did dark energy exist before the Big Bang? According to some theories, dark energy may be a remnant of an energy field that existed before our universe formed. Its characteristics suggest a hidden force that might have played a role before the Big Bang. Some hypotheses even propose that dark energy, in a much stronger state, could have influenced the inflationary stage, causing rapid expansion. The presence of dark energy implies that, even if our universe were emptied of all matter and radiation, this force would continue shaping spacetime. This idea raises an intriguing question. If dark energy existed before the Big Bang, could it have created the conditions that led to our universe's birth? Could dark energy be the hidden architect of inflation, or even the true beginning itself? Cyclic cosmology, a universe without a beginning. Another theory, cyclic cosmology, offers an alternative to the idea that the Big Bang was the ultimate beginning. This theory suggests that the universe undergoes endless cycles of birth, death, and rebirth. In this model, the Big Bang was not a singular event but part of a never-ending sequence, where universes emerge, expand, and eventually collapse, only to give rise to new ones. If cyclic cosmology is correct, there was never a true beginning, just an eternal cycle of universes being created and renewed. This idea challenges our understanding of time, suggesting that it might repeat rather than move forward linearly. If this is the case, what existed before the Big Bang could simply have been a previous version of the universe, continuously regenerating itself. For scientists, this theory provides a compelling explanation for the origins of the universe, proposing that there is no definitive beginning. Instead, the cosmos has always existed in some form, challenging our traditional notions of time and existence. Gravitational waves, clues to the pre-Big Bang universe. Gravitational waves, first detected in 2015, offer another intriguing clue about what may have existed before the Big Bang. These ripples in spacetime, caused by massive cosmic events like colliding black holes or neutron stars, travel across the universe carrying information about their origins. Some physicists propose that gravitational waves from the pre-Big Bang era could provide insights into the universe's state before inflation began. If detected, these waves might offer evidence that the Big Bang was not the absolute beginning but rather a transformation from a prior cosmic state. These subtle signals could unlock new knowledge, altering our perspective on the universe's origins. Just as the Big Bang left behind cosmic microwave background radiation, pre-Big Bang gravitational waves might carry traces of a deeper cosmic history, perhaps even of a multiverse. The search for answers. As scientists continue exploring the depths of space, the question remains, what existed before the Big Bang? With theories pointing toward quantum mechanics, multiverse hypotheses, and cosmic inflation, we may be closer than ever to uncovering the universe's deepest secrets. While a complete answer remains elusive, our understanding of cosmic origins continues to expand with every discovery. As we investigate these theories, we must consider how they might fit together to form a larger picture of existence itself. Until then, we are left with a profound mystery, one that propels both wonder and science into the vast unknown.